GAVRT is a way that students can learn about science by doing real science. So a key part of what we do with GAVRT is we want students using our big radio telescope to do science that's worthwhile and a good use of the telescope time. Teachers talk about the need for engagement, for getting the students to want to pay attention to what they're doing in class. If I walk into your classroom and say, today we're going to look for life in outer space, I've got 100% engagement. Every kid is interested.
So SETI is Search for Extraterrestrial Intelligence, and we gather different frequencies and then we compare that file to another one that was taken on a different date and see if any of the frequencies match up, and that could be a candidate.
We search for black holes, look for black holes, new ones that we haven't found before, so we're just collecting data for that.
We look at stars, constellations, we look at different galaxies and planets and learn new things about them.
We work with a maybe 20,000 ton telescope that is here in California, and we get to move that.
This is DSS-28, our 34-meter antenna that students use from the comfort of their classroom to look into the universe.
For a lot of the students, when they push a button in their classroom and they're watching the video of this huge radio telescope and it starts to move because they made it move, that moment is when they suddenly realize this is different. So I'm the project scientist for Juno, which is a spacecraft that's orbiting Jupiter right now. And one of the science campaigns for GAVRT is students observing Jupiter from the ground with our radio telescope. Science that they do, observing Jupiter on a day-to-day basis or a week-to-week basis over the course of years, is valuable to our mission with the Juno spacecraft at Jupiter. So in some sense, they're part of the Juno science team.
Well, GAVRT really is our flagship project. It's our partnership with NASA JPL, and we've actually just celebrated our 20th anniversary. And it's really just an opportunity for our students to partner with scientists and participate in real ongoing science work by participating in different campaigns or missions or projects with our JPL scientists.
The coolest part about it is just the fact of radio astronomy, and we're looking at objects that are so far away that they happened millions of years ago. It's coming from something that may not even exist anymore. It takes so long for that energy to come to us. So it's almost like looking into the past.
The goal is to get students working hand in hand with JPL scientists, collecting data for existing campaigns, analyzing the data, and then delivering the data, and potentially I would even like them to use the data to support their own hypotheses and their own ideas.
The fact that we said, okay, we're going to trust you with this multi-million-dollar piece of equipment. We're going to let you do something real, and we're going to ask you to help contribute to the world, to contribute to the world's body of scientific knowledge. That whole thing, that responsibility, can change the way a kid looks at life and looks at school.